The radioactivity is a random phenomenon. So there's no rule guiding it. Now, if you have a nucleus of an atom that is unstable here, there is no guarantee that it will be undergoing disintegration now or anytime soon. There is no way we can decide. It is a random process. So radioactivity is a random phenomenon. The distribution of radiation rate is expected to follow a normal distribution pattern. In other words, if we use this instrument to measure the number of radiations for a period of 1 minute, and if we measure it for about half an hour, now do you think each minute you get the same number of radiations? No, it will be completely different. Each minute you get a different number of radiations. Now, how will they be distributed? You see, one characteristic of a random phenomenon will be they follow a normal distribution. We call it a bell-shaped distribution. Now, if you have heard anything about statistics, you will understand the meaning of a bell-shaped distribution. Well, we're going to look at the distribution of this. I measured the background radiation of this room for 42 minutes. I took the counts for each minute. I used actually this equipment. I turned it on and I can set it for each minute count. It will count for a minute and will give me that number. And then I do it for the next minute. I did it for 42 minutes and I got these numbers. Now, the first minute I had 25 counts. It means there were 25 radiations detected in this room in the first minute. The second minute there were 17. Third minute there were 12, then 22, 21 and so on. And I did the experiment for 42 minutes. I spent most of my morning doing this experiment because this is the one I'm going to use it to show you. I did another sample for you to work with. Alright, you know what I did? I divided these values into 7 classes. Now what does that mean? Now if you look at these numbers, there are numbers greater than 20, numbers between 15 and 20 and so on. So what I did is I counted how many numbers are from 5 to 7. If you look in here, watch here, I have there is a 7, there is anything else in that class? Yeah, there's a 5. So in this group, that is how many 5 to 7 are there? There are just 2. There is a 7 here and there is a 5 there. So from 5 to 7 there are 2 values. Now how many are from 8 to 10? Now what I did is I wrote each numbers. You see, you can go and do like this. Let me show you how to do that. Okay. I wrote these like this. Alright. Greater than 5, greater than 10, greater than 15, greater than 20. I sort of classified like that, and when I take each number, 25, I write 25 here, 17 I write here, 22 I write here, then 21 I write here, 9 I write in the top one, 12 come here, 16 is here. So you look at the way I'm dividing these. I said how many are above 5 and below 10. All those I will write here. And now, using that, I counted the numbers from 8 to 10, I got 6 of them. 11 to 13, I got 10 of them. 14 to 16, I got 11 of them. 17 to 19, there were 7. 20 to 22, there were 4. And 23 to 25, there were 2. You see, there is a 25 there, and there is a 23, there you are. So this 23 and 25, there are 2 of those between 23 and 25. Now, these numbers are called the frequencies, and these are called the classes. You see, my class 1 is 5 to 7. There are 2 values in that category. 8 to 10, there are 6. So 6 is called the frequency of that class. Now, this is the way these radiation counts are distributed. And now, I don't know how many of you know how to draw a histogram. I can now use these numbers to draw a histogram to see how these numbers are distributed. I'm going to take you to the next slide and show you that. Alright, now I have brought this over. These are the classes, these are the frequencies, and I'm going to show you how I drew the histogram. Now, a histogram is a graph. This is the x-axis and this is the y-axis, and I'm going to draw the frequencies, that is these numbers on the y-axis. The maximum I have is 11, so I'm going to go in steps of 2. Look at this, 2, 4, 6, 8, 10, 12. I need only go up to 12 because 11 is my maximum. And I go to the first class. In the first class I have 2 values. Look at that. I draw a rectangle that has a height of 2. This represents the frequency of the first class. Now the frequency of the second class is 6. I draw another rectangle that represents 6. The frequency of the third class is 10. The frequency of the fourth class is 11. The frequency of the next class is 7. And the frequency of this class is 4. And the last class is 2. So once again, and look at the distribution there. Well, let me go back there. Now, this distribution is called a bell-shaped distribution. It is a normal distribution. Any random process has a normal distribution. So, the radiation that you have around here, the background radiation, is a random process, and the distribution of that is normal like this. Okay, now this is what I did. Now I want you to do a similar exercise and send it to me. And in order to do that, I did a second trial. I did a second trial and measured the background radiations for 42 minutes and obtained these values. Alright, now you need to work with it. Divide these into 7 classes as shown below and count the frequency for each class. So I've given you the classes. How many values are here between 5 to 7? How many values are there between 8 to 10? How many values are there between 11 to 13? Alright, when I said between 11 to 13, both those numbers are included. How many are there from 14, 15, 16? How many are there 17, 18, 19, and so on? So fill in the frequencies and draw a histogram of these frequencies. All right? And complete the worksheet. I have also asked you some questions, a simple question based on what we did.